Hey guys, welcome to our day 2 AP calculus review. So yesterday we discussed problems 1 up to 6, and now we're gonna continue. We do problem number 7. And if you guys have questions, just let me know, okay? So this is the graph of this particular problem, and it says approxim- I mean approximations to the definite integral from 0 to 4. So it's from here up to here, right? Inclusive. This is the interval. So f of x dx, where f is the function whose graph is shown above, uh, are made using left Riemann sum. So we know what left Riemann sum is. So starting left, going to the right. Okay. So then a right Riemann sum. So right going to left. Okay. And trapezoidal sum. So this is a combination of three, right? Using or each using four subintervals of equal width. Which of the following is true? Okay. Now, I'm gonna do color coding for this one. The black color is the function, right? The given function. And what you notice with this given function, decreasing or increasing function? Decreasing function. Okay. So, decreasing function. So I just leave that as is. That can I just put t as the function? Okay. T. This one is the t. So color black is the t function. Okay. So let's do color blue as the left. Okay. And we do color red as the right. Okay, what is your idea on left Riemann sum? If the function is decreasing function, left Riemann sum over estimate. So to have that, we say over estimate if the graph is decreasing, right? Decreasing function. So over estimate. And how about the right Riemann sum? Underestimate. Okay. So underestimate. It's red color. Okay, underestimate. So we're gonna do color coding now from interval 0 to 4. So we do left Riemann sum. So left Riemann sum, where to start? But we have this trapezoidal sum. So it's a combination of three, left, right, and trapezoidal sum. So what you notice on trapezoidal sum, now we can only do trapezoidal sum provided that we have 2 points. So I'm gonna highlight this one at 0 and right here. We can create a trapezoid if we connect the 2 points. Do you get me? Do you get me, guys? Okay. So I just use another color for this line so we can see. So I'm using green color. So can you connect? If you have highlighter, guys, please use also highlighter. So connect this. I hope I can justify a straight line, but if not, sorry, because this is lights all the time. Okay. More or less, more or less, it's straight, right, Sam? Okay. So let's do left Raymond sum. The blue color, right? Left Raymond sum. So where to start on left Raymond sum? Gonna start left. You get me? So left. So from here up to where? Okay, we have this interval from 0. Can we sketch each of this? So can we just have our base as 1 unit each? Okay, 1 unit. But I think I made a mistake on my green graph because what is asked right here, the interval is from 0 to 4. So I ended like 4.5. So can I erase first? Okay. So it must be here, right? Am I correct, guys? From 0 to 4. So we're gonna connect this. Okay. So let us have the blue color left Raymond sum. Left going to right. Get me? Clear, guys? Clear? Okay. And then the next is going to the right. And then going to the right. And then going to the right. Okay. I need you to shade the blue color. The blue color is the left Raymond sum. Okay? So, left Raymond sum. I forgot, but it's okay because I covered the black color, right? I should not be covering the black color, so I'll just trace that graph, the black graph. Okay, which means what you notice on the black graph, it's gonna be in between the supposedly in between the blue color and the red color. So this is now left Raymond sum, the blue color, right? So what you see, is this correct? Overestimate? Yes or no? Left Raymond sum. If the function is decreasing function. So overestimate. The blue is above the black color. Did you get me? Now, let's have the right Raymond sum. Where do the graph starts or the right Raymond sum starts? Starts from right going to the left. Okay, right. So this is the rightmost. This is the rightmost. Okay, and then it's gonna be going to the left. But so it should be where? So right here. Left to right. Right to left, right? So next, right here, and then right here, and right here. Okay. So can you shade the black color? But we are not shading below the green. Correct? Okay. So I'm gonna delete this. So We are not shading under the green. Up. Sorry. Oh. So can we shade now the red color? So it must be this area. This area. Okay. So as long as you shade. So the blue is over the red, right? The blue is overestimate and the red is underestimate. So, question. Which of the following is true? L, what is L again? The overestimate, which is the left Riemann sum. So, therefore, the T, which is the black color, is between left Riemann sum and right Riemann sum. Is this statement is true? For this, less than. Is it less than? Yes, no. Tell me honestly. Raise your hand if you choose this one. Less than? No. Okay. Very good. How about letter B?
Yeah, no. No.
In terms of T,
Yeah,
But, no.
I believe.
is red color less compared to the blue from
Yeah.
T as our base,
Yes.
right? Yes. So what is our best answer for this one?
B.
Okay, very good. You made a right decision. So does this helps you? Yes. Okay. Now, don't dare to choose letter C because R is not in between, right? This is not the right option. And also, this one is not the right option because T, the black graph, should be in between. You get me, guys? That is why I said a while ago, this is very controversial because if you don't do it this way, then you might be at a loss. Okay, guys? Is number 7 clear to you? Okay. You don't have to solve, but you just analyze by doing left and right Riemann sum. Okay. Sounds good? So moving on to, can you close the door? It's annoying. So next is number 8. Okay, number 8, guys. Oh. Two. I cannot control right here. This is 6. Next week. Okay, let's have number 8. A particle moves along the x-axis with velocity function, so vt, okay, and acceleration function at. Which of the following gives the average acceleration? So average acceleration, guys. So when we say average, what is in our mind? It's gonna be 1 over f of b, or 1 over b minus a times the integral, right? Okay. Now, average acceleration. So I need you to highlight average acceleration. Or simply, what we learned last time was just f of b minus f of a over b minus a, right? Okay, b minus a. Or simply written as, since the word is average, so I need you to, if you have other color for the word average, what comes in your mind, this is antiderivative. So you already know that if it is average, it's gonna be the difference of the intervals divided by 2. Did you get me? Divided by 2. So we can rewrite this as b minus a, the integral of f of x dx, from interval a to b, and then f of x dx. This is the formula for average. Okay, average. So, and what is the given interval of time? From 0 to 10. Do you get me? So that means if we plug in this now, it's going to be 1 over f of b minus f of a. So we have 10 minus 0. Do you get me? 10 minus 0. And what is the interval? From 0 to 10. And then what does it say? A particle moves along the x-axis with velocity function, vt. Velocity function. So this means this is vt dt. Do you get me? Okay? Vt dt. So simplifying further, what is 10 minus 0?
10.
It's going to be 10, right? So it would be 1 over 10, the integral from 0 to 10, and then vt dt. So this would be our final answer. So from
C.
so it's going to be letter C. Okay? Any question? Rigonta? Are you sure? C? This is and acceleration function at. Are we done? So, what will be our final answer?
D.
Letter D. Because it says acceleration function. Okay? Clear now, guys?
Yes.
I intentionally did this one because this is the original function. So what is the derivative of velocity? Acceleration. Is this derivative? Yes, right? So, but what is that given original function is velocity. So you go acceleration, you go down. Very tricky question, right? Very tricky. Because I myself at the start, and I thought that this is the right answer, but no, because I go back to the question and I analyze. The question is really going to acceleration. from the velocity. Okay? So, moving on to number 9. Number 9 is easy. Okay? I cannot control here. So, you're number 9, right? Oh dear. Now, can you read the problem for me for number 9? Hi Chris, I miss you. Are you okay, Mijo?
Yeah, I was doing something.
Okay.
What are we doing?
So, uh, Chris Ramirez, can you read the problem for me, please?
Really close to the trash can, sorry.
So, from 0 to 5.
Particle moves along the x-axis. The graph of the particle's velocity v is shown above. Over the time interval 0 to 5, what is the particle's displacement?
Displacement. Okay. So, what are the options right here for this displacement?
27/2.
Okay.
50.
So, it's gonna be velocity. Okay, particles velocity. Sorry. So the interval is from 0 to 5, inclusive. Okay? So 0 to 5. If this is a particle that starts at 0, so right here, and then the particle is going right here. So at the start, I'd like you to do this one, guys. Draw this one until 5. Okay, and we're gonna cut this. Okay. Now, there are times that the problem is very familiar and doesn't require a lot of solutions, but we're gonna analyze the graph. Remember, we are on area, okay? On antiderivative focuses on area. So, if you box that one, I'd like you to count how many square units are there for a rectangle. Take a look first on the rectangle. You do later the triangle. Okay? So this is composite graph. You get me? So, can you tell me, Cleo, how many? 15? Okay. Now, will you agree
Yes.
that in this rectangle there are 15 square units? 15. Okay. And then how about the triangle on top?
4.5.
4.5? Okay. 4.5. So we expect that our answer is sure 4.5.
Yeah.
Okay, then can you add them up? What is the area? 19.5? 19.5? Okay, but look at the options. Look at the options, guys. The 27 halves is for 26.5, right? So we cannot choose this. The 15 is just the area of this one. We cannot choose this. How about 24? Does this reaches 24? No. What is 39 halves? 19.5. Okay. So C is the right answer.
You wanna go?
Any question?
You want to? Car for nobody.
And moving on to number 10. Number 10 is for us to analyze. We don't have to solve, but we're gonna analyze the unit. Diego Rodriguez, can you read the problem, please?
For number 10?
For number 10.
In the definite integral of vt dt, v represents the velocity of an object measured in meters per second, and time t is measured in seconds. What are the units of integral of 0 and 50 v velocity vt dt?
So, units. We are on velocity. Normally, what's the unit? But consider that velocity as your given function. Vt dt. So, what do you think is the unit? Huh? T. Velocity of an object measured in meters per second. Meters per second. So therefore, it's gonna be meters, right? You're right. You said B. Who said B? Okay. Good job, Josue.
Thank you.
So, it's just analyzing, right? We don't have to solve. Okay. Moving on to number 11.
Clean as a whistle.
This what it looks like.
This is also very controversial because some might argue on this, but I need you to look at what is the given condition. So, Manny, can you read the problem, please? Just start on this one, the table above.
The table above gives selected values of the twice differentiable function t of x in degrees Fahrenheit of the outdoor temperature, where x is measured in hours after 6 a.m. for a 12-hour period. Which of the following statements about the average outdoor temperature, 1/12 on the integral of 0 to 12 tx dx are true?
Bobby, keep yourself safe.
Okay, so we have A or I or 1 using left Riemann sum with 5 sub-intervals. So before you say the statement is true or false, you're gonna have to do first the height, right? The height. Okay, so how many sub-intervals? 5, right? 5 sub-intervals. Therefore, we do sub-intervals right here from 0 to 1. And what's the next sub-interval? 1 to 4. And the third sub-interval is from 4 to 7. The fourth sub-interval is from 7 to 9. And the fifth sub-interval is from 9 to 12. And you know what to do, right? So, I'm gonna have this. 0 minus 1. So, it's gonna be 1. 4 minus 1. It's gonna be 3. That's the height. And then 4 minus, 7 minus 4 is also 3. And then 9 minus 7 is 2. And then, of course, 12 minus 9 is 3. Okay. Is this clear now? Okay. If we have this as a rectangle, this is the height, right? The height of a rectangle. 1, 3, 3, 2, 3. Always remember that, because right here on number 1, number 2, and number 3, it's very tricky. Okay? Now, let's do number 1. What is number 1 all about, Joseph?
Number 1.
Yes. It's all about,
You want me to read it?
it's all about what?
Left Raymond sum.
Left Riemann sum. Very good. Left Riemann sum. So, here, this is the technique for left Riemann sum. You look at the height. What's the first height right there? What's the first height? 1. Okay. Go to the height and your direction is towards left. If it is tabular. Do you get me? If it is tabular. Therefore, you go right here. Boom. That's left Riemann sum. So I'm using red color. Okay? And what's next? What's next, guys? 3 to 62. Get me? And what's next? Another 3 to 75. And then 2 to 80. And the last is 3 to 89. Do it that way. That's your guide. Okay? For left Riemann sum. Okay. So, this is gonna be, it says, using a left Riemann sum with 5 subintervals, indicate the data in the table, the average outdoor temperature. Now, temperature starts from 0 up to 12, right? Okay? 12 hours. Okay. So that means average. So the word average, it's gonna be f of b minus f of a over b minus a. So b minus a, what is this? 12 minus 0. So it's gonna be 12. So 1 over 12. You get me, guys? Okay, 1 over 12. Is this correct? 1 over 12. Look at the red direction. 1 times 55. Is this correct?
Yes.
Next, 3 times 62. Is this correct? Next, 3 times 75. Is this correct? Next, 2 times 80. Is this correct? And the last is 3 times 89. Is this correct? So this statement is true statement.
Which means B is wrong.
Okay? So the first statement is true. Now, let's go to the next direction. I'm using green color for right Riemann sum. That means from the height above, where to go? The direction. To the right. So, look at this. I'm using green color for number 2. 1 to 62. Does it follow?
Yeah.
1 times 62.
Yeah.
Next, 3 times 75. Is this correct?
Yes.
Next, 3 times 80. Is this correct?
Yes.
Next, 2 times 89. Is this correct?
Yes.
And the last is 3 times 87. Is this correct?
Yes.
So this statement is also true. And there might be an argument tomorrow in terms of option number 3, because this is very tricky. Do you get me? What is next? I'm gonna use what color you want me to use, guys?
Orange.
Shall we use purple? Okay, for the trapezoid. So using a trapezoidal sum with 5 sub-intervals, indicate by the data in the table. So what is trapezoidal? Directly from the height, you're gonna add this divided by 2. Do you get me? So that means 55 plus 62 divided by 2. Or we shall be writing also as aside from 1 over 12, right? Because 1 over 12 is the average. So is this 1/2 of 55 plus 62?
Yeah.
Is this statement correct for this one?
Yeah.
Yes, right? Okay, next. Directly from 3. So 62 plus 65. So that means 1/2 times 62 plus 60,
75.
3 times rather, 3 times 62 plus 75 over 2. That means 3 halves. 3 halves. Do you get me? 3 halves. Is this 3 halves?
Yeah.
62 plus 75? So this is correct. So the third one, same thing, 3 halves, right? 75 plus 80. Is this statement correct?
Yes.
Now, can you continue by yourself for the next one? Whether it is correct or not. And then I'd like you to argue.
It's
What do you think?
It's wrong.
Manny?
It's wrong.
Any observation?
For
Valid
80,
reaction.
for 80 plus 89, it's 1/2, when it should just be 1 instead, because it's
Say it loud, Manny. Say it loud.
for 80 plus 89, it should be 1 instead of 1/2.
Instead of 1/2. Will you agree with Manny?
You said to argue.
Oh my god. The height.
Say, so what's your argument,
The argument is
Josue?
that, everything is divided by at least 2. So
Look at the height.
I'm looking at the height. Don't worry. I'll get there for a minute.
Manny said, look at the height. Oh,
Tell me, mommy.
That's 2 divided by 2.
Obviously 1/2. I'm kidding. It's one.
ah,
It's one.
so will you agree with Manny?
I will agree with that.
So this is error, right? This error. This is error.
Oh no.
Because it should be 1,
Mm-hmm.
right? Because the height is according to Manny. Look at the height.
Yes.
And Manny is right.
Man,
The height is 2 and 2 divided by 2 is 1, not 1/2. So this statement is false. Did you get me, guys?
Yes.
Very tricky, right? So which of these options are correct? A, B, C, or D?
See.
It's gonna be option C.
Let's go, Manny.
This is debatable because some might say, oh, this is correct. No, it's not. They might have the option to choose letter D, but letter D is not the right one based on this given problem, unless this is correctly written. Right? Okay. So moving on to number 12. Number 12, we are still basing our answer from the table. So can I just do it that way? You guys see?
Yeah.
We're gonna base our answer for number 12 from the table. And what does it say? Which of the following is the best interpretation of 0 to 12 t prime of x dx is equal to 32? Okay. Now remember, what does it say? It starts after 6 a.m. 6 a.m., right? So therefore, we're gonna start, consider this 0 as 7 a.m. You get me? And then next as 8, 9, 10, 11, 12. So therefore, it's gonna be from, what do you think?
From 6 to 6.
6 to 6. Okay? 6 to 6. Okay. Now, we all know that our option should be from 6 to 6. Are we going to consider A?
No.
Test taking strategy? Knock out A. So we're gonna knock out A. So what are the candidates? B, C, and D. But we're gonna analyze. Shall we look for letter D first? From 6 a.m. to 6 p.m., the outdoor temperature increased by 32 degrees Fahrenheit per hour. What do you think?
Yes.
Per hour? 32 degrees?
Heck no.
So,
Violent reaction.
from the table, what did you say, Chris?
Violent reaction.
Violent reaction. So, yes, no?
No.
It's a no. You're right. Okay, let's take a look on option B. What is option B? Diego Martinez?
From 6 a.m. to 6 p.m., the average outdoor temperature was 32 degrees Fahrenheit.
Average. Average outdoor. Remember, you know what average is, right? Can we choose this as average? No. So therefore, the best option is letter C. From 6 a.m. to 12 p.m., the outdoor temperature increased by 32 degrees Fahrenheit. Okay?
Oh, it's C.
No way.
It's C with you?
Letter C.
I thought it was B for the average.
Yeah.
I thought
Huh?
it would be too long.
But it didn't tell us average. It changed it. You're right.
Temperature. Not average, but just increase. Right? Remember, if our answer is positive, increase. But what about if it is negative? Decrease. Okay. Moving on to number 13. Okay. How much time is left, guys?
3 minutes now.
Huh?
4 minutes.
3.5 minutes.
3.5 minutes. But do we still have time to discuss number 13?
I do not think so.
There's a red and there's black. Which I don't think it's which color.
The red is on your left, the black is on your
Right.
Do we have time? Yes or no? Okay. Because we're gonna solve each one of this.
What?
Oh, then
Yes.
we don't have enough
Yeah, we
time.
don't have time.
There's no time. There's no time.
2 minutes.
Is the answer A, Mr.
Huh?
Is the answer A?
No.
A, B, B.
It's A or B. Either one of those.
Yo, it's one of those four answers.
It's gonna be letter B. Why? Why you notice interval?
9 and 2.
9 and 2. F of B minus F of A.
Subtract them, yep.
9 minus 2.
What is it, B?
Yeah.
7. But look at this.
Minus.
Square. Remember, we did this last time?
Yeah.
Mhm.
No, I don't remember.
Remember, this is how to write the limits of the function
Limitation.
as n approaches infinity. And then the summation, a equals 1 to n. And then 9 minus 2, 7 over n, plus, we still have, or minus k, but k is right here negative 1, so negative times negative 1 turns to positive 1 and then square. Okay?